Okay, so this is my second attempt. Apparently, I spent an hour recording something that had no sound. So I'm just going to read through this with you guys since I've already done it. I'm not going to redo it. So what do we have here? Let's recall that circles are of the form radius is equals to a real number. Lines are of the form theta is equals to some k, a real number. Cardioids are of the form r is equals to a plus or minus a cosine of theta, which is oriented along the x-axis. Or r is equals to a plus or minus a sine theta, which is oriented along the y-axis. The side radii, of course, are a. The large radius, singular, is twice a, and it intersects the pole. Limacons are of the form r is equals to a plus or minus b cosine theta, which is oriented along the x-axis, or r is equals to a plus or minus b sine theta, which is oriented along the y-axis. And of course, the side radii are still a, however, the large radius is a plus b, and we do have a small radius, right? Small radius is the absolute value of a minus b, because there are two different cases, right? If a is larger than b, then there's no inner loop. And if a is less than b, there is not only an inner loop, but we intersect the pole. So let's recall that if you're given a complex number, z is equals to radius times a quantity, cosine of theta plus I sine of theta. This implies that the complex nth roots are given by z sub k is the nth root of r times a quantity, cosine of the quantity, theta over n, plus 2 pi over n times k, and quantity, plus I times sine of that same monstrosity, where k counts from 0 to n minus 1. So there are indeed n roots, because n minus 1, we have 0 to accommodate. So now we're going to talk about roses. Roses are of the form either, number 1, r is equals to a cosine of n theta, or number 2, r is equals to a sine of n theta, where petal length is a. If n is odd, there's n petals spaced evenly around the circle, so 2 pi radians divided by n. If n is even, meaning it's divisible by 2, we multiply by 2 to have the number of petals. So if it's divisible by 2, we multiply by 2 for the number of petals. So 2n petals spaced between 2 pi radians reduces to pi over n spacing. So let's note, cosine of n theta equals to 1 means that theta has to be 0, because cosine is 1 at 0. So for cosine, the first petal will be along the positive x-axis, or theta equals to 0. For sine, however, if sine of n theta is 1, that means n theta has to be pi over 2, because that's where sine is 1. So dividing by n, we get that theta is pi over twice n, and that's where the first petal for sine will be, along theta equals to pi over twice n. So for example, if we plot r is equals to 3 cosine of 4 theta, we've got a petal length of 3, and we've got n equals to 4, meaning we're going to have to double that because it's divisible by 2. The petal length is 3, and since it's cosine, the first petal is along theta equals to 0. So the 8 petals have to be spaced into 2 pi radians, so every pi over 4 units. So I start my first petal at 0 radians, and then I tick off every pi over 4 radians to where I put my next petals, right? And then I just draw a nice little daisy or rose, quote, quote, rose, which looks like a daisy, connecting all of those to the pole. Now let's do r is equals to 5 cosine of 3 theta. So in this case, the a is 5, that's a petal length. Since n is 3, it's not divisible by 2, so I just have 3 petals. So the spacing is 2 pi radians divided by 3. So every 2 pi radians, we have a petal, and the first petal is at theta equals to 0 because it's cosine. Okay, so what do we have next? We have r is equals to 4 cosine of 2 theta. So the length is 4, but since 2 is divisible by 2, we have 4 petals. So the spacing is 2 pi radians divided by 4, or every 90 degrees. And of course the first petal, since it's cosine, will be along theta equals to 0. And then every 90 degrees, or pi over 2 units, we place another petal at a length of 4 from the origin. And then we draw our lovely rose. You might recognize this as, complex nth roots, kind of. Okay, so what do we have here? R is equals to 2 sine of 3 theta. So the petal length is 2. N is 3, which is not divisible by 2, so we have 3 petals. So the spacing is 2 pi divided by 3 petals. However, the first petal is at pi over 2n. So since n is 3, it's going to be pi over 6. So my first petal is at pi over 6, and then I go from there 2 pi over 3, or 120 degrees away from 60, which is 150, right? Sorry, 30. Holy free holy, this is 30. I'm like, what's going on? That doesn't make sense. Okay, so 120 away from 30 is 150. Another 120 puts me at 270, or 3 pi over 2. So we have a trefoil, or 3-leaved rose. Okay, so now we have r is equals to 3 sine of 2 theta, where the length now is 3, but n is 2, meaning it's divisible by 2, so we have 4 petals. We're going to space those 4 petals into the 2 pi radians evenly, so every 90 degrees. And the first petal, being at pi over 2n, will be at pi over 2 times 2, which is pi over 4. So here's my first petal. And every 90 degrees, I have another petal. And there we go. We connect the dots with a nice, lovely daisy-like shape. So here's one that I wouldn't give to you on an exam. I just wanted to show it to you. So we have radius is 4 times cosine of 5 theta. So the length is 4, but this 5 petals, well, the spacing is 2 pi over 5. Well, 360 degrees times 2 is 72. So 0.5 times 360, which is half of 360, is 72 degrees. So this is actually, let me write this, 2 pi over 5 is 72 degrees. So my first petal, thank goodness, is along theta equals to 0 because it's cosine, and every 72 degrees after that, I have a petal of length 4. Lemnis sets are of the form either r squared is a cosine 2 theta, or r squared is a sine of 2 theta, and have petal length plus or minus square root of a. So note that we have both squared and 2. Those have to be there. Squared and 2. If you just have 2, that's a rose. You need squared to get a lemnis set. So it's always r squared and 2 theta. So note, cosine of 2 theta has its first petal along theta equals to 0, and sine of 2 theta will have its first petal along theta equals to pi over 2 times 2, or pi over 4. So let's plot the following lemnis sets. If we have r squared is 9 cosine of 2 theta, well, if I plug in 0, cosine of 0 is 1. So I get r squared is equals to 9, or r is plus or minus 3. So at 0 radians, I have my radius is plus or minus 3, meaning it's either in the positive direction 3 or in 180 degrees away from that 3. At pi over 2, twice pi over 2 is pi, but we get r squared is negative 9. That doesn't work. At pi, we get r squared is 9 again, because 2 pi is 0. So we're right back to where we began. So then I tried pi over 4. Pi over 4 times 2 will give us pi over 2, and cosine of pi over 2 is 0. So at pi over 4, my radius is 0. So that's what this guy is referring to here. Okay, So now, without further ado, cosine is an infinity symbol or lemma set that's oriented along the x-axis. And it has radius, square root, plus or minus a. So, given that, if we have r squared, remember we have to have r squared, is 4 squared cosine 2 theta. It has to have a 2 and a squared. That is a lemma set. Then it's just plus or minus 4 along the positive x-axis, and we draw our lemma set. For sine, however, let's try r squared is 9 sine of 2 theta. So once again, let's start with 0. Well, sine of 0 is 0, so r squared is 0. So we have 0 along theta equals to 0. At pi over 4, 2 times pi over 4 is pi over 2, which means that sine of pi over 2 is 1, so we get r squared is 9. So at pi over 4, we get plus or minus 3 as our radius. Okay, where was I? And then once again at pi over 2 times 2 will be at pi, we're back at 0. So we just go back and forth. Okay. So given that, sine, the lemma set for sine is always along pi over 4 because we're always dividing by 2. We're always dividing pi over 2 by 2, so it's always pi over 4 because that's what a lemma set by definition always has the 2 inside the argument. So given that, all I need to know is a square root of a, and I do plus or minus a along the line theta equals to pi over 4, and we have our lemma set in the direction of sine. So I'm sorry I did this so quickly. I just spent an hour doing it the long way with no audio. So I'm just exhausted. Hopefully you can pause this and take notes because I don't know if I'm able to upload the notes to Canvas because it's that bad right now. So hopefully all will go well, and I will see you, knock on wood, on Thursday for your final. Okay, good luck, guys.